Welcome to this Quantum Security and Defense presentation. Quantum Time Transfer, Using Entangled Photons for Resilient PNT Applications, and thank you for being a valued member of our community. David Mitlyng is the CEO of Xairos, a startup building a global timing service to expand beyond GPS. David has 3 decades of experience in the space industry, including Hughes Space and Communications, Orbital, Maxar, and BridgeComm. David has a BS in Aeronautical Engineering from Cal Poly SLO, a MS in Aeronautics and Astronautics from Stanford University, and an MBA from the MIT Sloan School of Management.
Excellent. And please stop me if you're not seeing the charts or if you can't hear me. No, I really appreciate this opportunity, Anna.
Just to say, sorry, I forgot to say, we typically do, unless you want a different format, that you give your talk and then we take the questions in the end and then people can post them in the chat. Is that okay for you?
Oh, no, that works perfectly. And so my chart's about 10, 15 minutes. So hopefully that timing works out well for you and everybody.
Great.
All right, excellent. So it is my pleasure to be here and talk a little bit about what we're doing at Xairos, and particularly with quantum time transfer. I know the goal with this the quantum security defense community platform really is to look at the security applications of quantum. So I'm going to talk a bit about how we're using entangled photons for security, for secure distribution of time, for position navigation and timing applications. So I think most people on the call here in the audience are quantum experts, so this may be fairly high level, but we are in the middle of the second quantum revolution where we're manipulating the quantum properties of individual particles for very amazing applications. For the general audience that's quantum curious, when you think of quantum and quantum technologies, your mind typically goes toward quantum computing and quantum computing companies. But really, there's a lot of work being done on the lesser known areas of quantum sensing, which include things like atomic clocks and very sensitive inertial gravity and magnetic field sensors, and quantum communications. A lot of people confuse us with quantum computing or quantum sensing. We are in the quantum communication realm, which means that we deal in the world of photons, specifically entangled photons. The nice thing about working in the world of entangled photons is each entangled photon is considered a qubit, but like a flying qubit. And it leverages more mature hardware based on very advanced optical and laser technology that's been developed over the decades, primarily for the distribution of symmetric encryption keys, what they call quantum key distribution. But there are other applications out there for using entangled photons, both the sources for entangled photons and single photon detectors. One of the other major applications that's being used quite a bit is the creation of truly random numbers, what they call quantum random number generation. There are now companies that have chips that are in your cell phone that are creating these provably random numbers for security applications. It becomes then a seed for cryptography reasons. There's also quite a bit of research in quantum metrology and quantum imaging type things, including quantum radar and quantum LiDAR, kind of using the entangled photons to sense or detect, distant objects with, fairly accurate and low, power applications, which have a lot of value for certain, particularly military applications. And then the other one that's getting a lot.
Watch the full presentation on the Quantum Innovation Community. Simply search for QSecDef.com.